to show you how to solve a system of linear equations using a matrix inverse. Now, to start with, I'll just explain what we mean by system of linear equations. So here we have a set of equations. These are expressed in terms of these variables, x1, x2 up to xn. Each variable is multiplied by a coefficient, aij, so a11, a12, etc. These coefficients are just scalar values, numbers, for example. And on the other side, on the right hand side, we have constants, values b1, b2, etc. and these are known as constants. Now, the solution to this set of linear equations are the values of x1, x2 all the way up to xn that satisfies all of the equations in the system. Now, it's often convenient to express a system of linear equations in matrix form, so that's what we've done here. We have the matrix equation AX equals B, where A is a coefficient matrix. So this is a matrix containing the coefficients of the variables. X is a variable vector, so there's a column vector containing the variables x1 up to xn. And on the other side of the equation we have the vector B, which is a constant vector which contains the constant values. Now, solving systems of linear equations using an inverse, we have the equation AX equals B. Now, A is a matrix. Now, if A has a inverse, we can multiply on the left hand side by the inverse of A. That on the left hand side, that will give us the identity matrix multiplied by X, which is of course just X. And on the right hand side, we'll have the inverse of A multiplied by B. So this is how we solve a system of linear equations using the inverse. Okay, so we're going to solve this system here. Now, in a previous video I showed you how to calculate the inverse of this 3 by 3 matrix here, and we saw but it was 160 times 1 over 60 multiplied by this 3 by 3 matrix. So this is A inverse and this is the vector B. Okay, so we're simply going to multiply the inverse of A times that vector B, and we end up with this, and this simplifies quite nicely to the solution. So x1 is equal to 1, x2 is equal to minus 3, and x3 is equal to 2. Okay, we can check this solution. If we multiply A by our solution x, we should end up with the constant vector B, and as you can see I've done that here. So if we multiply A by x, we can check whether we have the constant vector B, and of course here we've seen we've got the correct solution.